Very good morning or good afternoon or good evening to everyone watching this video. So this video is going to be the behind the scenes version of my app, that is Emask. And here I'm going to take you through the code and all the components used and the internal working of the app, which helps it to classify and how it is going to classify the data. So for this month's Atal Lab challenge, we had to use machine learning in order to solve the problems. And so my app is basically a mask recognition application which will recognize if the person is wearing a mask or is not wearing a mask. So it is essentially an image classifier, and hence I have used the personal image classifier from the MIT App Inventor website, which I have imported into my project. Okay, so let us go to screen 6, which is the heart of the code. Let me go to the block section where the code lies. Okay, let me show you the designer section one. So as you can see, I have imported personal image classifier from the MIT App Inventor website, and I have also imported it into my project. And as you can see, I have also imported by machine learning model. Okay. So this is the website that I used to train my machine learning model. This is not the real model which I trained, it's just a demo one. So as you can see, I have used classifier.appinventor.mit.edu in order to train my machine learning model and perform the mask classification. So what I did was I dragged in two labels, one for mask, one for no mask. And then I uploaded files from my system of people wearing masks and into the mask label, and people not wearing mask into the no mask label. Okay. And then I trained my machine learning model over here, and then I tested it over here, and then I finally downloaded it from here and imported it into my project over here. Okay. Let me now briefly take you through the code of this app. So as you can see, we have initialized three variables, that is model names, category, and confidence. Okay, so model names will basically store all the labels which are obtained from the personal image classifier. For example, mask or no mask, confidence, etc. So all those labels. So we are creating a new empty list called model names, and storing all of the information there. Then we are initializing the global category variable to an empty string, which will basically later on store the result of classification, that is mask or no mask. And I have initialized confidence to 0, which will later on store the level of confidence with which our machine learning model has predicted the result. So as you can see here, there are two blocks, one when the classifier is ready and one when there's an error. So when the classifier is ready, we are displaying a small error message in label file called status ready, and we are also calling the personal image classifier to get the model labels. And if there's an error, we are displaying a small error message. Okay, so when the labels of the classifier are ready, we are going to store all those labels in the list we initialized earlier, which is global model names. So we're going to store all those labels in global model names, and we're going to make all the icons visible, so all these icons are in horizontal arrangement 1, and we're going to make them visible. So when button 1 is clicked, which is essentially the camera icon, we are going to call the personal image classifier to classify the video data. And when button 2 is clicked, which is basically the switch camera button, we are going to call the personal image classifier to change the camera facing mode. Then we come to the main block of our code, so which says that when the classifier got classification, that is once it is done classifying the data into mask or no mask, so we are going to obtain all the items in the list, and we are going to set the global category to whatever is obtained, that is the first element of the list. We are going to set confidence to the second element of the list. There are many more elements, but here we are going to use only two, that is category and confidence. And then we are setting the label font size to 25 and the color to white to make it easy for the user to read it. And then we're going to check if the category is without mask. Then we're going to print in label 3 that mask no, and we're going to print the confidence percentage. And if the category is not mask, that is if the category is not without mask, we are going to print mask yes. Okay. Okay. So So an MIT App Inventor, a variable which is initialized and which has a value in a particular screen, has the value only for that particular screen and not in any other screen. So therefore, if we want to use a variable from this screen in an other screen, we have to call a tiny database that is embedded into App Inventor called tiny database. And then we are going to store all these values in that tiny database under the category tag and confidence tag. We are going to store both the variables, category and confidence, under their respective tags. Alright. So why do we have to do this? Okay, so we are doing this in order to make the user view his previous results when he goes to the classification center of our app. Alright. Okay, so this brings us an end to the behind the scenes version of my app. I hope you like the video. I'm Manju Mandali, the developer of this app, signing off. Okay, bye bye. A very good morning / good afternoon / good evening to everyone watching the demo video of this application. The application is called MAsk. MAsk is an intuitive and user-friendly application developed by me for the accurate recognition of presence of mask. So opening the app, we are taken to a welcome page which welcomes the user, encouraging him to get testing now in a mask testing laboratory. Clicking on the continue button, we are taken to the home page of the app, which has 3 different buttons leading us into 3 different locations. The first button, which says Go to Lab, takes the user to the mask testing laboratory where he can test for the presence / absence of masks. The second button, which says Go to Collection Center, takes the user to the collection center where he can view previous diagnosis reports of his previous scans. The third button, which says Library, takes the user to a library of information about the various features and development tools of the app. Clicking on the Go to Lab button, the user is taken to the mask testing laboratory. Okay, let me enter the laboratory by opening the door. So opening the door, we are presented with 2 options, one for continuous scanning and one for single picture scanning. So the continuous scanning option is ideal in use cases where a large number of pictures is to be scanned and a large number of recognition processes are to be performed. This is ideal in commercial spaces and shops where a large number of users are to be tested. Single picture scanning, on the other hand, is ideal in use situations where a small number of users are involved, a small number of pictures are to be scanned. So clicking on the continuous scanning button, the user is taken into a page which displays the various suggestions that need to be followed for accurate results. Let me click on it to make it disappear. As you can see, the camera of the phone has been activated. Okay, and 2 icons have appeared at the bottom. One for changing between the front and rear cameras of your phone and one for capturing the image. So let me click on the change camera icon in order to change to the front camera of my phone. As you can see, I have focused the camera to my mouth and nose region before clicking the picture. And as you can see, the result of my test has appeared on the left in the bottom bar, which says no, which means that the person is not wearing a mask, with a confidence level which appears to the right, which is 47.334%. Clicking on the single picture scanning button, we are taken to a screen in which 2 icons appear. One for capturing the image and another one for switching between the front and rear camera. So focusing on my mouth again, mouth and nose region, I click on the capture button and click on the tick icon in order to view my diagnosis report, which says that the person is not wearing a mask and displays a bar graph of confidence which is 48%. Okay. Going back to the home page, clicking on the Go to Library button, we are taken to the library of information, and entering the library upon opening the door, we are displayed a wide range of infographics about the development tool of the app and the various features of the app with the logo of the app in the center. This brings us an end to the demo video of this app. Thank you so much for watching this video. I'm Manju Mandali, the developer of this application. Until the next one, bye bye.